Now we are in question number 3. So in question number 3 we can see a graph which is basically a quadratic curve, and it says that figure shows part of the curve with equation y equals to x squared plus 3x minus 2. So this is the equation of the curve, and if you can see in the curve properly, there is a point called P as well, which is basically 3, 16. So the question says the point P 3, 16 lies on the curve. Find the gradient of the tangent to the curve at P. So basically I'll be using these spaces so that we can complete the entire problem with the questions on the screen. So for part A, the question told us to find the gradient of the tangent at P. So basically we know that for a curve, gradient of tangent is basically dy by dx. So where y is equals to x squared minus plus 3x minus 2. So if you differentiate it, we know the basic formula of differentiation, that is dy by dx of, suppose a constant time x to the power n is basically k into, we can take the power in front, and then we have to minus from the entire power, so which gives us kn x to the power n minus 1. So we will follow the same for this expression, so which gives us the power is 2, so we will put the power in front, 2 x to the power 2 minus 1. So it's basically 3x. 3x means that the power of x is 1, so which gives us 3 into 1 x to the power 1 minus 1. So if you differentiate a constant, it gets a 0. So this is basically 2x, and x to the power 0 is basically 1. So 3 into 1 into 1, or I can show it like 3 into 1 into x to the power 0. X to the power 0 is 1. So that gives us 2x plus 3. So at P, what do we know? That at P the coordinate is 3, 16. So at P the gradient of tangent is basically, we have to put the value of x over here, so which gives us 2 into 3 plus 3, which is 6 plus 3, that is 9. Okay, so this is part A. So for part B, let's see the question at part B. So the part B says the point Q with x coordinate 3 plus h can also lie on the curve. Find in terms of h the gradient of PQ. Write your answer in the simplest form. So basically, if you see that the x coordinate of Q is 3 plus h, and they told us to find the coordinate of PQ. So in order to find the coordinate of PQ, I know the coordinate of P, that is 3, 16. So I need to find the coordinates of Q. So as Q lies on the curve, so for part B, first I need to find Q, coordinates of Q. So for Q, x is equals to 3 plus h. And for y, it's basically 3 plus h whole square plus 3 into 3 plus h minus 2. So if we simplify it, it gets us, you can expand this using a plus b whole square. So that gives us 9 plus 6h plus h square plus 9 plus 3h minus 2. So simplifying it, this gives us 9 plus 9, that is 18. 6h plus 3h, that gives us plus 9h plus x square and minus 2. Sorry, I forgot to simplify that, minus 2. That gives us, so 16 plus 9h plus x square. So this is the x coordinate and y coordinate of Q. So in order to find the gradient of P, I'll be using the coordinate of P, that is 3, 16, and the coordinate of Q, that is 3 plus H, 16 plus 9H plus H square. So gradient of PQ, so basically what we know that to find the coordinate between two different points, the formula is y2 minus y1 divided by x2 minus x1. So let's consider this is x1, this is y1, and this is x2, this is y2. So basically we will find the differences and then we will divide it. So putting in this formula, we get 16 plus 9h plus 8 squared minus 16 divided by that is x2 minus x1, so that gives us 3 plus h minus 3. So we get this gets cancelled off and this is get cancelled off, so we get 9h plus h squared divided by h, so which gives us 9 plus h. So if we divide the numerator with h, so it gives us 9 plus h. So this is the simplest form of the gradient of the line PQ. So this is part B. So part C, the question says, explain briefly the relationship between B and A. So understand that for part C, let me explain. So understand that what we found in part A was gradient of tangent at B. So at P, the gradient of tangent at P, which was like dy by dx. So at P, we found gradient of tangent was tangent, which was equal to, if we go back to the question, go back to part A, which was basically 9. So from part A we get at P the gradient of tangent is 9. And from part B what we get is gradient of P and Q, where P also lies on the curve and Q also lies on the curve. P and Q, which is basically 9 plus h. So if you look at the two expressions properly, understand that 9 is the gradient of tangent at P, and PQ, the gradient of PQ is 9 plus h, which means that if h tends to 0, what does h tends to 0 means? H tends to 0 means that Q is approaching P, that Q is basically equal to or equivalent to P. If h is 0, then Q is basically, Q tends to be P. If h tends to 0, then Q tends to P. So basically at that time this represents, when h tends to 0, this represents gradient of tangent. So this is the relationship between B and A. So from A part we know that the gradient of tangent at P is 9, and from B part we get the gradient of PQ, where Q also lied on the curve and P also lied on the curve. So the gradient of PQ was 9 plus h, and the relationship between two is, if h tends to 0, then Q tends to P. If h tends to 0, then the point Q almost get very close to the point P. So basically this, at that time, this represents the gradient of tangent.